Hello, guys. Welcome. Hi, Chris. Hi, David. Hi, Mark. Oh, wow, lots coming in. Hello, everyone. Welcome, welcome. Just going to give it a minute for people to file in. The invariable Zoom update, but I can see numbers still coming in nicely. So welcome, welcome. While we're waiting, just to start, my name's Steve. I'm joined today by Nicholas of O Innovations. Now, rest assured, we can't see any of you guys at the moment, so it should just be myself and Nicholas on screen. For anyone who's not been on one of these webinars before, like I say, we can't see or hear you guys, but we do hope you'll communicate with us. And the best way to do that is by asking questions. So somewhere on your screen should be a speech bubble with a question mark inside and Q&A written underneath it. If you click on that, it should open a little text box where you can type a question and that will then pop up on our screen. And we will get through as many questions as we possibly can. The format of the session is going to be initially, Nicholas is going to talk us through the journey of O Innovations, what they've accomplished, what's next, and then we will move on to more of an open question and answer session. Great. Right, Nicholas, is your sound on?
I think I am. Yeah. Can you hear me well?
I can, yes.
Perfect.
Okay, I will pass over to you.
All right. First of all, let me just welcome everyone. I'm very glad to see some names that I've talked to, of people I've talked to before, but also some former team members, which is very nice to see. Let me just jump into the presentation so we can start then with the Q&A soon after. This one. It should be an image of the, yeah, you can see it now. All right. So first of all, my name is Nicholas. I'm originally from Chile, now based in the UK. And I am the original inventor of the O-Wind Turbine and founder of O Innovations. Let me just tell you the story from the beginning. I'm going to try and make it brief, but I think it's a nice thing to see. There we are. It's 2006 when I was finishing my undergrad. I did product design, and as a last project, I had to find a challenge, and at that time I was working with wind. So I found an interesting experiment that NASA was doing, thinking of exploring Mars by using basically a beach ball that would be taken by wind through the surface and do experiments and take measurements on the way. So that was, to me, a very clever idea. But one line in Mars wouldn't provide that much information. I thought if you wanted to explore a wider area, you would need more than one. But again, if you put a number of them together in the same place, the wind would take them all together, drawing the same line, which wouldn't make that much sense. So the solution for me would be a device that would use wind to go forward, no matter what the direction of the wind was. So I challenged myself to design my own device. I built this prototype, roughly 2 meters diameter, took it to the Atacama Desert in Chile, which is the closest we have to Mars on Earth, and did 6 trials, which went 17 kilometers in total. That to me, well, it proved that it could take crosswinds to go forward. And that for me was a huge success because I finished university with highest distinction, which I'm very proud of. And I keep very nice ties to the university. But after that, I just went on to work. I packed the idea thinking at some point I should do something with it, perhaps explore the possibility to generate electricity with it. But at that time, it was just a bug in my parents' warehouse. In that time, since then I started working with startups, research centers, and universities, always in the innovation space, developing products from TRL 0 to roughly 7, which is my sweet spot. So from concept to organizing ideas, putting things together, and finally building prototypes, testing them, and getting them ready to be mass produced. In 2016, I decided to go and study a master's degree, again, international innovation, in the UK. So we came in with my wife and two daughters, and we spent the next 2 years between the UK and China, which was all part of the program. But at the end of it, I came across the possibility to apply for the James Dyson Award, which would basically reward anything that would solve a problem. So I dusted off the old design, turned it into the omnidirectional wind turbine, and put it in the contest. I built a couple of prototypes, tested them at the university in Lancaster, and the contest went well. This gentleman said it was an ingenious concept. And we won the national phase, but then it's a contest that's held simultaneously in 27 countries. So all of the winners then compete for the international award, and we got that as well. And that was massive. We spent the next 6 months answering the phone, emails, and approaches from the media. We were featured in at least 150 media articles, but also TV, live TV, books, radio, and whatnot. It was a hectic time, but very, very rewarding. So in that time, we managed to put together a team. Yassine, who you can see in the images, and Dominic, who joined afterwards. We started the company, founded it in 2019, and we all put a little bit of resources and started raising accelerators and awards and other things. So we could start developing bit by bit, very slowly. It was that was the case until 2022, when we actually raised enough funds for me to come back to UK and turn it into a full-time job. From then, we have tested and tested and tested in different ways, built different prototypes with whatever resources we can find. We have spent roughly £700,000 in doing this. What you can see on the pitch deck on the Crowdcube side is 440, but that's hard investment in the company when formed. So money coming in before that, and on the form of HMRC returns, tax returns for R&D expenses and VAT. They're not counted there, and in-kind support as well, and other awards. So roughly in total, 700,000, which have helped us to run all of these tests in different ways. In that time, we have also won 8 international awards, been exhibited in COP28 plus 7 globally renowned museums and science centers. Also, we have run at least 6 accelerators and have done at least 7 university projects. So it has been a lot of work all of this time. We have been quite silent on the network, on the social media, but believe me, it has been a lot of work. And we have validated, right now we have this 70 centimeters diameter prototype, which is the one to the right in white. That's the latest one. That's version 3, which is roughly 3 times better than version 1. And we have tested on this pilot that you can see to the left. That's a 6 meters pole with a 70 centimeters prototype on top. And that has helped, but it's been there since December 2022, so nearly 3 years. And that has validated the absolute absence of any environmental impact. So no noise, no birds and bat strikes, no insects whatsoever, and no flicker effect, which are the most important things that keep people from loving the large wind turbines. But also, we have validated power output and mechanical resistance, which is very important, as you'll see. So that's where we are now. We have tested a lot of that. To the left, you can see the acoustics from the acoustic teams from Salford University testing noise. They didn't have anything to report because nothing could be heard on top of the noise of the wind, which is very, very encouraging. So next step is we have 70 centimeters now, and that has worked and validated everything we need to validate. The next step is to go for the 2.2 meters diameter, full size, to be installed in a location with a customer who was actually waiting for us to build the first one and install it with them. This is University of London, which is under NDA, so I cannot name them, but we are ready to go there. We just need to build this one, go there, install it, and validate it and show to the world that it actually does what we're saying it does. That's if the raise reaches the lower the minimum raise, which is 150,000. With that, we can do the first one. If we reach more than that, and the cap is 500,000, we can do the first batch, which is 10 to 20 units that we can then use to keep doing more pilots with different customers to try it in different situations for consistency of the data. And we can demonstrate publicly that it works consistently, but also certificate. So that time would be, that first batch would be for piloting and certification. That would be roughly a year. So first 6 months, first pilot, next 6 months, first batch and pilots. And then we're going to be ready to go for the production phase, which starts with DFM, which is design for manufacture. That could take anywhere from 3 to 6 months, and then we can start producing them. So launch time is hopefully 2027. Of course, things can happen in the way, but that's the plan. We have found out everything we need to find out at this point, and we are pretty confident that we can make it work. So thank you very much for listening. I hope this brings a lot of questions and we can spend some time discussing.
Thanks, Nicholas. Now, Giuseppe has raised your hand. Are you able to type into either the chat or the Q&A, please, if you have any questions at all? There's a couple of hands that have gone up, so I'm hoping they're not saying that you can't hear us. But if there is a technical issue, if someone would put that in the chat, that would be great. But for any questions, just type them out, and we'll just work through them as we come, rather than doing the hands up and getting people speaking them, if that's all right. Okay, so we've had a few in, because I think it's a busy session, and I think we're going to have Elliot says chat is disabled. So if I think I did do that. So if we can type the questions into the Q&A, just so they're all organized, I can see which ones have been answered. That would be great. We will jump straight into the questions though, and I can see there's a dozen in there already. Okay, so let's get started. So Richard asks, what technical readiness level are you? I assume 5, if not tested fully in real environment between buildings.
No, we haven't tested in between buildings. That's the next phase. But so different TRL levels are defined differently, but roughly TRL 6 would be the match, because that's testing a full system in a relevant environment, which is not the final environment. That's TRL 7. So yeah, I would say 6.
Thank you. And then a couple of questions about the performance, and I suppose this might have a couple of answers, depending on whether we're talking about the 70 centimeter unit or the projected 2.2. So Ed asks, what sort of power output are you getting?
Right. So every measurement we take, we then forecast for the 2.2, which is the main our main goal. And the 2.2 in high energy potential spots, which I can explain further, would mean 3,000 kilowatt hour per year. That's what we expect, 3,000 kilowatt hour per year in a place with high energy potential. Yeah, I don't know, Steve, do you want to expand on that, or maybe we just go with the questions?
I think with the questions, we will, because we've got quite a few, I think we'll run through with a reasonably top level answer, and then if we find ourselves, if people want to ask follow-ups, and we've got time, then we'll do that. And this is kind of linked, but it says, what's the efficiency of the turbine? I'm not sure whether there's a more technical answer than the output.
Yeah, it is related, but more importantly, more than efficiency. The question is for us is not how efficient you want to make it, is how much energy you want to generate with it. And efficiency is one of the ways to make more energy out of it, but it's not the only one. There are other factors there, and one of them that's actually much more important than that is wind speed. So that's where it comes down to high energy potential spots. Because briefly, there are places within cities and in some rough terrain where the wind gets accelerated, funneled by buildings and other obstacles, and accelerated. So wind tunnels, the way we usually call it in the street. In these places, the wind can go up to 3 times the speed. And that's where the energy is. That means up to 27 times the energy potential. So that's where we want to go. It's not about efficiency there. It's about being able to harness that wind. It's roughly like trying to go off-road. And every car now is a race car. And you're going to go to a place that's really rich, but you cannot get there because you don't have the car to go there. So this is the first off-road car, the first 4x4. It will allow us to go there. And by doing that, we're going to be able to generate a roughly 5 times what you can generate with the most efficient turbine on an open space. So it's not about efficiency, it's about generating more power. And 5 times the power means it's really important.
And so just while we're on that power, I'm just scanning through to try and link through a few kind of themed questions. But someone just asked, compared roughly what would a 2.2 meter turbine equate to roughly in solar panels? I don't know whether that's something you can do, but just to give a kind of sense of, it might be one you need to sit on for a moment, but
yeah, it could take me a little bit longer to try and do that, but yeah, I would have to do a couple of calculations. But let me just say, solar panels, well, how many hours and all that? No, it'd be longer. Because they are calculated on a kilowatt base rather than a kilowatt hour per year. So I haven't run the numbers for that, but I can absolutely do that and get back in writing. So please leave your email there and I'll go back to it.
Yeah, for anyone whose questions either we don't get round to or need a bit more detail, we will share an email at the end of this so that there can be either more in-depth conversations or follow-ups or call separately with Nicholas. Okay, let's keep on the product at the moment because there was one about wind speed, and I don't know. I mean, what essentially saying is it's not quite a comparing like for like with other turbines because it's an off-road turbine. But let's see the question. Yeah. It is, how many kilowatts at which wind speed will it generate? So the tests of this 3000, roughly what wind speed is that?
Yeah, well, I'm just going to dive into it because I guess a number of questions are going to go in that direction. So let me just share my screen once again. This is just one slide that I thought might be useful. Not entire screen now, just that one. All right. This is the best explanation that I can provide as a comparison point. To the left, you have the vertical axis wind turbine that claims the highest efficiency in the world, as far as I have seen it. So you go to all these other providers and developers, and whenever they provide a power curve, that's what I'm using. So it's a claim. I'm not saying they actually do that because I haven't tested, but they work between 0 and 15 meters per second. At that point, they stop because it's dangerous for those turbines to work any faster in any faster wind than that. On the other hand, we are aiming to work up to 25 meters per second, and we have actually tested up to 28 meters per second, and it does well. But let's keep it at that, also for safety reasons. So in the UK, you have places where the average wind goes from somewhere between 4 and 5 meters per second. In this case, we're talking about Manchester, which is 4 meters per second in the last 10 years. In HEPS, so high energy potential spots, this wind is going to be accelerated up to 10 or 12. So you're going to have an average of 12 meters per second. So with this different arrangements, they work in very small wind, so they won't take the high cost. They will be able to generate 605 kilowatt hour per year. We will be able to develop between 2,000 and 3,000 kilowatt hour per year. That's finding high energy potential spots of average 10 meters per second or 12 meters per second. And that's a big difference.
Thanks, Nicholas.
Yeah. Other than that, there are the issues down there: noise, birds and bats, flicker effect, and the structural integrity, which is the biggest issue there. I wouldn't dare putting one of these wind turbines or horizontal axis wind turbine in one of these positions because it's dangerous. They can bend and break and fly out. So yeah, it's like putting a race car on the mountain. It just won't do well.
Well, let's move a little bit on to placement, because there's a lot of questions about the products, but I think we'll talk a little bit now about markets and where you see these being used. So main market expectations, and people are asking questions about things like domestic, whether there'll be a smaller version for domestic or leisure and that kind of thing.
Yeah, I get that a lot. I hope we will be able to develop something for domestic. The pipeline is basically the size and the first fit for the market, the 2.2 meters diameter, is calculated as a product that will be able to generate an ROI of 8 to 10 years to customers. So that's the calculation. If we can make something in time, make it more optimal, increase efficiency, increase power output in any other way, we will be able to generate smaller and smaller versions that will provide the same ROI. So that will come down in time. Now, in houses, what you have is a different situation. You not always have these large buildings creating downdrafts and funnels. So it may not be the case that for every house. Actually, it's less likely to have that situation in an open space than in cities or in rough terrain. Now, in places where you do have rough terrain, it is possible that you have the situation, but you would have to analyze that in a way that gives you some certainty before you spend some money. I guess many of the people here, because I've had conversations with a number of people who come in on the contact form and they ask this question because they have tried other turbines and they don't do well, basically because of two things. On the one side, many claim more than they can do, and on the other side, people don't know what the potential is in their places, and they bring in technologies that are not suitable for that particular type of wind. So yeah, we might be able to provide something for houses, but please make sure first you have something that you're absolutely sure that you have the conditions there. And for that, we do have partners who provide wind analysis at local level from 100 euros above. So depending on your situation, we can find the right suit.
Thank you. And so you mentioned potentially coming back smaller. So if the 2.2 meter is the initial commercial product, is 70 centimeters just a prototype, or is that the type of size you might come down to for maybe more domestic use?
It is only a prototype for now. We had at some point thought that for balconies, we might have a solution of 70 centimeters just because we need it for the device to go through the doors, and that's the size limit. And it might be able to do something, but I think now, after having analyzed and studied this for several years, a more suitable solution for buildings would be something that's put on the side of the building as part of the original design rather than something off the balcony.
And Ami asks on that, so talks about use in cities, and saying you had an image with it put up on poles, I think kind of lampposts. And the question was, can that be retrofitted to existing lampposts, or is it envisaged that there need to be infrastructure put in for these?
It might be possible. There will be different requirements from local authorities because it's something that's creating pressure on the pole, and the structure of the pole can be affected by the wind hitting the ball, right? So there might be something there that's not suitable, but in some cases it could be. So, for instance, communication towers and lighting towers, that kind of thing might be over designed, so over calculated, and that may be within the threshold. So it is possible, but again, it would have to be analyzed case by case.
Thank you. Now, just coming back to, you mentioned the ROI being targeted at about 8 to 10 years.
Mhm.
So there's a couple of questions. One is, how does that compare to broadly similar sized traditional turbines in terms of their payback? And do you have an idea of a kind of a target cost per kilowatt hour?
Yes. So the return of investment 8 to 10 years would mean we calculate from the cost of the grid towards the 3,000 kilowatt hour per year. So the cost would be roughly the same. Right now, the cost in the UK is average 26p and something else per kilowatt hour. So the cost would be exactly the same. And there was a second part to the question, sorry.
And how does that compare with traditional turbines of a similar kind of output?
Difficult to say because the experience from the people I have talked to who have bought these turbines is that they never pay back. Many of them, because of I won't blame it all on the device itself, but also on the location. Many of them won't even turn on the equipment most of the time. So it's really a case by case. Some technologies are really good, some others are just not what they say. But ROI in general is not there. So we are working hard and we haven't gone to the market yet because we don't want to just sell whatever we have as soon as we have it. We want to sell something that we can assure people that it would work, and then that creates good feedback and that generates a healthy market, right? Right now the market is not healthy. Many people are having bad experiences and there's just no standard there. So we want to break that cycle.
Understood. And just to save people from doing the maths, to get the approximate unit price for the 2.2 meter.
Yeah, so there is actually a discussion on the CrowdCube forum, and I do provide a detailed answer to that. But the short answer is 8 years would mean 6,324 pounds, and 10 years would mean 7,905 pounds. That would be a selling price.
Okay. So between 6 and 8,000 roughly.
Roughly, yeah. 6 and 8.
Okay.
6
6 and 8,
8,000. Yeah.
Okay, let's move on to a little bit of competition. We're getting some great questions in. I'm hoping we're going at a pace that's reasonable, but I want to get through as many of these as possible. So there's a couple of questions about competition, and one's just asking generally about what competition's out there, and the protections you have on it. That's from Elliot, but I'm going to group that one with a question of someone that mentions Darius and Savonius hybrid turbine. I don't know whether you're familiar with that, and if you are, whether you can just give us a very brief top level description.
Yep. The combination of Darius and Savonius is basically the one I showed before, the one I was comparing with. And this particular manufacturer claims that is the most efficient one in in the world. They have a very good starting point at very low wind speed, but again, they are targeting lower wind speed. So it's not something we're competing on. We're looking at higher speed winds because at lower speed, you can start delivering some energy, but if that doesn't even turn on the equipment, then it doesn't make sense. You can see it spinning and that's nice, but and reassuring, but in the end, it doesn't do much. So competition. Basically, I group them in two ways. One of them is that keep insisting in the traditional efficiency first approach, which is most of the cases, and others that are doing clever stuff and trying to find places where the wind gets accelerated. So on top of the house bridge or in different scenarios. There's even one thinking of typhoons in Japan. That kind of people, I think, are going in the right direction, and I am hoping that some of this will do well, and we can create a market that actually can deliver value with the products that we sell. Yeah, well, I just showed the market comparison. That's what's there. You can compare power curves and you can find those that are more efficient. But in the end, it's not about efficiency. It's about energy output. And that's the big message now. It's all about the energy. And there are many ways to go with the energy. There are actually, I'm looking at the formula now. It's 4 factors that go into generating electricity. The efficiency is one, but also the air density, the area or size, and velocity. The first 3 just multiply once. So and velocity, wind speed multiplies 3 times. So let me just read the factors again. So it's efficiency, air density, size, wind speed, wind speed, wind speed. That's how the formula is made of. So it's very clear where we need to go.
Understood. I'm going to ask one other little bundle of questions, and then I will take one on a question about the CrowdCube platform on your behalf. So this is about the actual construction.
Mhm.
So I'm going to group a few together. So we've got a question about what materials are involved, what maintenance is required, and things like lubricants used and will they need to be topped up, and the lifespan. So we've got the core materials, what maintenance will be required, and what's the overall lifespan of the expected lifespan of the unit.
So we're saying publicly, we're saying 15 years. I think it's going to be closer to 20. But yeah, if I had to stick to a number, I'm going to say 15 years lifespan. Materials. Our prototypes right now are carbon fiber, just because they provide a way to do molds cheaper, even if the materials are more expensive. So if we can do molds cheaper, that means less investment right now when we're trying 1 or 2 or 3 units that are not going to be mass produced. That's the strategy for prototyping, and that's what we're going to keep doing for the next year or so. But after that, for mass manufacture, that's going to be a different conversation, and we might shift to a different manufacturing system and materials. That's something we need to explore on the DFM phase, design for manufacture. And maintenance, well, we have this prototype that's been there for 3 years. We have kept doing changes to the prototype and to the setup, but altogether, there's never been a problem. We do identify possibilities to optimize and improve stuff, but it's never been the case that any bolts has gone off or that it starts generating friction or nothing that happens in time rather than anything that can fail happens at the beginning and we can improve that. So in the end, when we have a design that's fully produced in full size, that's going to have all of these lessons learned solved, and we don't expect many problems in time. Of course, as anything that has moving parts, there's going to be maintenance at some point. But for that, we're going to be developing a monitoring system. So we're going to know remotely what's going on with the turbine, and if there's anything off of the standards, we're going to have the possibility to go there and do some maintenance. So that's the way we're approaching it. We may not have a 1 year or a 2 year recurrent maintenance. We're going to have permanent monitoring, which is, I think, more optimum.
Thanks, Nicholas. Right, I'm going to give you a little bit of a break because you've just done 20 questions back to back. So I'm just going to answer a question from Paddy, who asks, if she buys shares through Crowdcube, how can I sell them at a later point? So Paddy's right, and I suspect most of you have come from Crowdcube. Crowdcube groups together investors and holds them under what's called a nominee. So the investor into O-Innovations will be Crowdcube, and they will manage all the underlying investments as part of that. Now, with investments in private companies, really the most likely exit is going to be when that company sells, which will be when that company gets acquired down the line. In some cases, it might be an IPO, but for the vast majority of companies, it tends to be that they're bought by a industry incumbent. And we can talk about that a little bit more, Nicholas, whether you see a turbine manufacturer diversifying into this kind of thing or another type of acquirer. But I think most investors looking at this should see that as the exit. There are talks on Crowdcube and other platforms that there'd be some kind of secondary share trading where people could put up the shares they own to sell to other investors. However, it's not a very active market, and that shouldn't be seen as something that's easy to accomplish. In fact, I don't think Crowdcube is actually actively doing that at the moment. But in theory, there could be other private investors who come along and offer a price for the shares. But for the most part, the return on investment will come on acquisition rather than any time before. Right. So let's get back. There's been a couple of questions around solar. One idea about whether the blades could be covered in PV material, whether that's a practical thing or whether it makes sense or not. But the other question where there's a few people asking about at what point does the unit start generating? There's a question about whether you talked about higher wind speeds being more optimal, but would it start to generate at, for example, 3-4 meters per second?
Yes. From some of the tests we have done before, it starts delivering energy from 3 meters per second. However, that's going to be related to your setup, really. Whatever MPPT you have or inverter, whatever that's connected to, that will have some resistance, and so it's going to be starting at different points. But as a device, we expect that to be 3 meters per second. Of course, it's not something I'm going to stick to. We're going to be working on more energy at the end of the day, and if that means leaving the cut-in point to a higher meters per second, then no problem at all. Because with 3 or 4 meters per second, fine, you can have it delivering. But if you only have a fraction of a watt, and it doesn't make any difference. And compared to that, you can improve a couple of kilowatts on the top range, on the top part of the range. Then, of course, you're going to want to go with the higher part. Sorry, before we go to the next one, Steve, acquisition, yeah, just to confirm, our intention is to get acquired at some point. But until that happens, we're going to keep developing the company, and there are plans to grow organically as well. But we have had conversations with large companies who have requested a number of details from the product that we don't have. They come in believing there's something ready to be sold, and at this time we still don't have it. But in a year's time, we will have the information, and that's going to be the starting point for us to have these conversations. And it's a matter of where you are in your your journey and how much value you want to create before you sell it. But I think it's pretty safe to expect an acquisition at some point.
And just coming back to competition mainly, we've got amazing list of questions. I do hope we can get through. We might have to run slightly over because I think it'd be great to get through as many of these as possible. But some of them, Nicholas, I think it might be worth doing an update after this to cover some of these. One of the ones is about power rating at different wind speeds and or power output at different wind speeds, and possibly a bit of a comparison with more traditional turbines. I wonder whether that would make a good basis for a longer read update.
Yeah, probably. Let me just go back to one that I didn't respond before. Sorry, I missed it. With photovoltaics as a material for the surface of the turbine, that will be a challenge that we can analyze at some point, but not yet, because there are a lot of complexities. First of all, it's a curved shape, so the panels that can do curved forms are less efficient than those, so that wouldn't be ideal. And there's weight and there's connections, and there are a lot of complexities to try and do that together, which could be explored, but right now we need to focus. That said, combining solar and wind is a solution. It's probably the most efficient way to go throughout the year, and that can happen in different ways. So yes, we will explore that both in time. The next question, Steve, the one just asked about the power curve. Yeah, that's something I mentioned a couple of times, and it's something I try to avoid answering in detail. And the reason is too many people are too inclined to think that efficiency is the most important thing. And as I said before, the industry has been going that way because they found a device that works, the horizontal axis wind turbines, 3 blades. Those are the most efficient ones right now. And the only one that can make it grow is size. So they go bigger and bigger. And that is efficient. That is that has created an industry around it. That's great. But if we want to keep at lower sizes, at this size, micro wind turbine, it's not about efficiency anymore. It's about finding the right wind speed and being able to harness the wind in those conditions. By the way, I'm not sure I said it before, but in these places, the wind is very, very harsh. It's not clean, it's not steady in direction and speed as the other turbines need to be. In this case, it changes constantly. It goes up and down, left and right, back and forth, and it changes very suddenly, and it does eddies and turbulence. It's messy. For that, you need a wind turbine that can harness it by not only being more structurally sound, but also able to harness wind from all directions and keep working in a continuous operation despite the changes. That's what we have now, and we are the only turbine that's capable of harnessing that. So again, power curve not relevant in this particular case because the competition is not about efficiency, it's about power output. And in the end, at the end of the day, if you compare us with the best competitor out there at this size, we do 5 times better if placed in the right location.
Thanks, Nicholas. Right, I'm going to try and do a few fairly quick questions. So, Ilga asks, is there a possibility to buy? We know that it's not yet for sale, but when's on the roadmap for potential sales?
Yeah, we are aiming for 2027. That's the goal. We don't have anything to sell right now, unfortunately. But as I said, 6 months to the first one, the next 6 months to the first batch. Then the first half of 2027 is going to be design for manufacture, preparing for launching the mass production. And second half of 2027 would be the launch time. And at that time, we're going to go probably for the first market version, which is in streets in the middle of cities with city councils and sponsors.
Great. Right, let's continue the quick fire. Have you tested it in snow conditions, and does the snow slide off?
No, we have had hail and we haven't had any problems with that, but not snow yet, not in the place where we have the pilot. So that's something to analyze afterwards, yeah, at some point.
And in terms of construction, Ed asks, have you considered graphene as a material for construction?
We have, yeah, and we actually had an approach from a company in Italy who claimed they could do this with graphene. Um, we didn't get to test it really to build a prototype, but it's something that might be suitable at some point. Of course, manufacturability and cost are still difficult to match, but yeah, it would be great.
And in terms of manufacturer and partners, are you looking at UK manufacturer, or have you identified anyone that would supply things like the power and control units?
Yeah, so manufacturing, we're basically at this point focusing on the rotor. So those are the main things. The rest of the equipment for now is going to be off the shelf until we have capacity from organic growth to start investing on our own equipment. But rotor-wise, we have a commitment with a partner company based in Hong Kong. We're going to be dealing with manufacturing. And let me tell you the full story there, because I think it is relevant. Last year, we were in a situation where one of our founders started a new company in Hong Kong, and he bought some of the patents, basically the ones in China, sorry, and the ones in Asia, including China, plus a couple of patents in the Americas, which include Canada, the US, Mexico, Chile, Brazil, and South Africa, plus the ones in Asia. And his aim is or their aim is to target the market there with different products. They're looking at a smaller size for something that's not going to be delivering much energy, but just enough to, well, it's not going to be delivering energy directly, but providing lighting and all the services. So that's a different product for a different market. We are more focused on the UK and Europe, and probably this is going to be the market fit for the Americas as well. So we're going to be targeting those together. And I mentioned that because part of the agreement is not only selling the patents, but also working together. So we are collaborating on development right now. We are more focused on technology validation, and they are more focused on manufacturability. So once we are ready, they are going to be ready, and that's going to be a quick jump into mass production.
Thanks, Nicholas. So let's talk a little bit more about that and the approach to sales.
Mhm.
So the question from Mark, and apologies, Mark, you were one of the first questions in, but just it's fallen later on. But yeah, what's going to be the sales strategy? Who are you going to target? Is it UK first or wider? Who's the key target and what's the approach?
All right. So this is going to be a long answer. There are three business models. Second and third are quite similar, so and easier to understand. So I'm going to just go through them quickly. Direct sales. So we sell products, they use them. That's the easiest way to do it. On the one side, to companies who may have the wind conditions within their facilities and they want to just buy one and use it. This could be universities, large industries, or real estate developers, that kind of thing, hospitals, stadiums. That could be a direct sell. The other direct sell could be out-of-home advertisement companies. These guys have billboards on big screens, that kind of thing. And they already have locations within cities that may be suitable for them, and they can install a wind turbine, an wind turbine on their devices to help support and reduce their energy bill and bring the advertisement space also to a net zero, or help bringing them down to a net zero. The first business model, which is the most important one for us and the one we want to target, is actually through sponsors. So first of all, we need to find high energy potential spots, HEPs. And that is done through computational simulations. We have partners who do that, and they can find spots within 1 meter resolution within a full city. So that's great. We do that. We found the places, and chances are most of these places are going to be located in public space within cities, in the middle of the streets or by the side of a big building. And I'm guessing many of us now in the call will have had an experience like going through the center, turning a corner and finding a big kind of a wall of wind hitting on you. Those kind of places are probably going to have to deal with the city council or the local authority. So we have had conversations with city councils, and they say, yes, we want it. It's great. They have signed letters of intention and support, but they don't have the money to invest. So for that, we've also had conversations and actually money contributions from a sponsor who wants to do that. They want to be the company who has the funds to do that, but they don't have the facilities or the wind conditions in their facilities. So they can place one of the units in a public space and they can sponsor it. And who uses that energy is going to be the local people, the community there, people who can be using that for charging devices or connecting to Wi-Fi, finding information. If it's a touristic place, it's a wayfinder, that kind of things that are basically everyone's needs. So in the end, the business is we install one there, we provide the energy for the people to use. The city council facilitates the installation of these units, and then sponsors not only get to get that turbine installed, but they also get to brand it and tell the story. And the best example is the live example. A couple of years ago, we were approached by Siemens because they were talking to a university and helping them in a university in London to reach net zero. The university was spending millions of pounds in technologies that would reduce their energy bills and all that. But everything was either on rooftop or behind walls, so it was basically invisible to people. And they want people to know about it, of course. So instead of doing billboards on digital media, which was actually a spend in money and carbon and a step back in their achievements, they would see this as a way to add one more tool to the pool of tools that would reach net zero, but that would be working in front of people. So in front of the public, people would see it, people would understand what they were trying to do, and they would be able to reach out to the full project through a QR code or an information panel or screen. So this is not only, there's a second value to this, not only generate the electricity that it generates, and it can match an ROI of 8 to 10 years because of that, but also the possibility to tell a story, to be there in front of people. So that's the business model that we want to go with because of two reasons mainly. The first one is we want it to actually work in front of people and validate itself and not be something that you hesitate on. We're going all in and make sure the message is well received. It's very clear that the energy is there. But also, we need to find the right locations, right? So if it's not in the right location, it's probably not going to do that well. It's not going to have the same PR. It's not going to have the same credibility. We want it to be in the right places. That's why we want to analyze the whole city, find the spots, talk to city councils, get installed in those exact places, and do as well as we can do. So there's no doubt that it can work well if you place it in the right location. And then we go to the mass market. So people now know when to install it, when it works, where it works, and there's no doubt of it.
So and is that international as well, when you say go to the mass market?
Yeah, first UK, because it's our local market. It's easy for us to be there if needed. But then short after, Europe, and then everywhere else. By the way, we do have patents and commercial rights in all Europe, and the 46 countries that the patents cover. Patents in the UAE, United Arab Emirates, and patent in Australia. Those last two are granted. The first one is pending. And then with all the patents that I mentioned, the rest of the world is open, so we can go there.
Right. I'm aware we have still got lots of questions to get through, so we will have to run a bit over. I'm trying to get through as many as possible. So next is a little bit about the company, because we've not really touched on that. So could you just tell us a little bit about the ownership and current size of the company? So people involved, your pre-revenue at the moment. That, just answering a little bit of the question there for you. And do you have plans to expand the board? So there's a bit of a question on ownership, company size, and whether there's plans to expand the board.
Yeah. Company size is 10 people involved, previous investors mainly. I have right now 51% and a bit more. And among the founders, we have, sorry, I'm loading. Yeah. Right before the round, founders have 75.21% of the company. After the round, depending on how much we raise, we're going to have, with the minimum target, 69%, 69.49% of the company. And well, if we raise more, we're going to be diluting, but we're not going to go below 50%. So we're going to keep control as founders. Then employees right now, full-time, just me, and Sam will join, provided the campaign goes well. And we have a network of advisors in different fields, in wind, on CFD, in business, materials and manufacturers, and a number of things. We have a network of several universities that we have worked with, and we can and research centers, and we can go to them with whatever questions we have. That's very much it, is it? That's the company size.
And just briefly touch on there's a few directors that have moved on in the last period. You're able to touch on that. Did you catch that, Nicholas?
No, sorry. It broke up.
Nicholas, can you hear me?
Yeah, I can hear you now.
Apologies.
It broke up for a little bit.
Great. Just in terms of the board and a few directors kind of moving on, is there
Sorry, you're breaking up. I'm not sure it's you or me.
Rehire, and just a little bit of context for that.
Steve,
oh, sorry. Any better now?
Yeah, I can hear you now. I'm not sure whether you're breaking up or me.
It was just a question about directors.
Yeah, directors. Yeah. We had
who are the
we had a board of 4 directors up to early 2024. At that time, 2 of them resigned, and then Dominic went on to start his own company, and to avoid any conflict of interest, he also resigned. We keep working together, but as a separate company. So right now, the only director is me, and I am looking to strengthen the team and create a new board, especially with someone on the role of secretary. And yeah, advisors. Well, we have a number of people who have offered to become advisors in different fields. So we're going to be building a new team with people joining in this round.
Great. Now, I'm aware that some people will have to drop off at 2. I think we stay on and answer as many questions. If people can stay, then fantastic. What I am going to just put in the chat, and I hope my sound is back now. But what I've just dropped into the chat is the link back to Crowdcube for anyone who wants to go and see more information there. please kind of follow the page to get updates, or even better, invest in the company. But there's also an email address there, inquiries@oinnovations.com.
Mhm.
We'll try and get through a decent slug of these, but I think it's unlikely we're going to get through everything. So if anyone finds that their question didn't quite get answered or they had a follow-up, then yeah, please just send an email to inquiries@o-innovations.com, and yeah, we'll get round to responding to that. Okay, right, I hope my sound's back now. Apologies for that. I think it's
It is.
okay.
Yeah.
Let's try and get through a few of these fairly quickly if we can. So Mark asks, what about using things like chimney tops? So placement on residential, is that a likely route?
Chimneys, it is a clever one because it would make use of the wind hitting the roof pitch, which could be very useful. But the quick answer is I don't know. I don't know how much wind you can pick up on that, and I don't really know about the structure of the chimneys, which could be tricky as well. So in theory, yes. Industrially, maybe even more so, but we haven't done the test yet or the analysis.
Thank you. And another one that's slightly linked. There's a couple of questions just talking about integration with solar, both kind of the how well it couples, but also whether it can integrate into solar inverters.
Well, it depends on the inverter, really. I have to say I don't know everything about inverters. I haven't dived into it. But we are working right now, our tests, we have an MPPT, maximum power point tracker, that does receive solar and wind at the same time. So at the minimum, there are equipment that do it. Whether it can match or it can use, if it can use the one you have at home, that's, I don't know. There are so many different inverters out there. I wouldn't know.
Okay. And there's quite a few people offering use of or asking questions about test sites, and whether you're looking for any test sites at the moment, whether people can get their hands on them early for testing. Is that something you're looking at the moment, or a little bit early?
I wish I could take over on all of them. A couple of things. Well, first of all, I am very, very grateful. So many people have offered me places to test. And I hate to say we don't have the capacity yet to establish more pilots. That's probably something we can explore in the second half of next year when we go for the first batch. But that said, since we need to demonstrate that it works in harsh conditions, we will need to find the harshest environments to go and try. So first of all, we will need to do a wind assessment in the places that we think could match the bill. And that's probably where we're going to be testing. But also, that not only works as technical validation, but also commercial validation. So it would be even better if we can find real customers in the target markets that we're looking for. So in this case, we have already found this university in London who might be in a good position to take it over. So that would be an ideal customer. Rural houses would have to be in very accidented terrain, maybe top of a hill, but maybe more so in a space between two hills, where the wind may go up in a funnel way. Those are kind of the ideal situations. And then geographically, it would be easier for us to make it closer to the UK rather than anywhere else in the world. But all of that can be done possibly if we have the resources. So who knows? We may have those conversations.
Thank you. And then there was a question about high wind speeds and at what point it would kind of cut off, or any kind of safety mechanism where the winds get too strong.
Yeah, 25 meters per second. That's our threshold.
And what
Currently,
happens to the unit if wind speeds are above that?
it will increase the resistance. So in the end, it produces more, but reduces the ROI, the RPM, the rotational speed.
Okay. And one from Mark says, is there an engagement with the government or anything, or any kind of schemes for getting power closer to the demand rather than in clean wind environments? Is that one of the routes? Is there incentives to get power generation in cities, for example?
Sorry, I missed the word there. Just go to the
It's
part.
asking whether there's any incentives or engagement with the UK government. Are there any schemes that look at
Right,
production of power in cities?
right. To my knowledge, there is a VAT saving scheme, so renewables can go through that. The only thing is, in order to be that there, you need to be MCS certified, and that means a further step. So once we do the first pilot, then we do the first batch. Some of those are going to be used for certification, and at that point, after being certified, we might be able to connect to the grid and do all of that. Before that, I think it's just going to be off grid, but VAT may be something to look at. Other schemes I'm not very familiar with, to be honest. I know there are some for solar, but they have restrictions. Um, but even though the money is there, not many people know about it.
Thank you. And then Mark asks about what are the main commercial hurdles? What are the production obstacles in getting to volume? Where do you see them produced? And a question that I don't know if we touched on earlier about, oh no, you did talk about the patent, so you don't need to cover that again. But yeah, what are the hurdles in terms of production and getting to volume?
Commercial hurdles could be more on the installation side. If planning permission are required, that could take time and increase cost. That I see as the main threat to it. That said, there are some situations in which it could be permitted development. But that has two restrictions. On the product side, it cannot be more than 1.38 square meters, which matches the 2.2 meters diameter in our case. 3.8 meters, sorry, 3.8 square meter swept area, which matches the 2.2 meters. That's why we have decided to go up to that size. And it cannot have a reflective surface. Those are the two main requirements for product. Then on the installation side, there are distances from the limit, from the ground, from the next building, and all the things that need to be covered. So not in every place we're going to be able to match that. And it would mean we might need to go through planning permission most of the times. So that's the main one. On the manufacturing side, it is a complex shape and it's difficult to collapse. So shipping could take some space. But that said, it's nothing other industries do and solve all the time. So I don't see a big problem there.
Thanks, Nicholas. Now, the price you mentioned earlier when we talked about that range of 6 to 8, is that for the turbine unit itself, or is that taking into account things like inverters or batteries or installation, VAT, that kind of thing?
That is the turbine installed. Yeah. So any other equipment to match it up with whatever setup you have at home or other things that's separate. But we're considering manufacturing and providing generator and like internal equipment for the turbine and physical installation. That's the price range.
Thanks, Nicholas. We have a question about, is Africa on your roadmap after Europe?
Yes, there is a market there, and the requests that I've had from Africa are basically for places that have uncertainty on the grid. The only thing is, I'm not aware of it. I haven't been there, so in any of the countries in Africa, and I'm sure there are differences between them. But our wind conditions require accelerated wind, and it would mean more suited for the larger cities rather than for open spaces. And whether there are hilly spaces, that would be also a good condition. So not just anywhere, not in the open spaces, probably. But that's the way I would approach it. We don't know much about it yet.
And another question that was actually asked quite early, and I should have brought earlier, do you envisage these being hooked up and feeding into the grid, or more that these would form either kind of direct or off-grid solutions?
Yeah. Well, for any renewables, it makes more sense to use them behind the meter rather than connecting to the grid because you make more of it. You get paid very little if you connect it to the grid. But yes, it can be connected to the grid after we have it certified. So once we go into mass production, and that's still a different market. And when I mentioned direct sales to real estate developers, for instance, that meant if you're building or designing a large building, you can use this on the side of the facades and optimize the wind for that. And that will be connected to the internal grid of the building. And there is an option to connect them to the main grid as well. But I think that the smartest thing to do is just to save energy first and then start using from the grid.
Understood. Okay, I think we are potentially on the long home straight now. I think we're getting through quite a lot. There's a question about, I think you answered this actually earlier, about the noise at higher speeds. I think you said in the tests the noise of the wind was greater than the noise of the turbine. Is that right?
Yes. Well, that's what you can say just by being there. My perception is that there's nothing to be heard. But what we did with the acoustics teams from Salford University is they went there. They attached, I think, 8 microphones very close by and further along, and they tested for an hour, maybe 2 hours. And in the end, they couldn't report anything because the noise of the wind. I mean, let me say it again. They couldn't hear anything on top of the wind noise, which matches my experience. Basically, you cannot hear anything really. There's nothing annoying about it, or nothing even perceptible about it.
Thanks, Nicholas. And a couple which I think have been answered already, but I'll just recap so that they haven't. So the production start was 2027, is that right?
Yes, that's the goal. Yeah.
And the power curve and the means of safety to prevent over rotation. Did you say that sharing that? I think you said sharing that in comparison to others is not quite as insightful as we might think it is, because it's focusing slightly on the wrong metric. Is that right?
Yeah, correct. And maybe I can just reinforce the idea. Thinking that efficiency is the best way to go to create more energy is the traditional way, right? But there's more than one way to generate more power. Again, in the formula for wind power, there is the coefficient of performance of the efficiency of the turbine, air density, the area, and wind speed. That's how it's composed. So why would you try and increase something that you can only generate small increases when you can go to something that can make a 25 times increase? It's just, to me, it's all right. They have done a lot for the industry with that, but at the same time, at this size, when the size is limited, then the only thing you can do, or the smartest thing you can do, I think, is going for wind speed. And comparing efficiency, it's okay. We can do that, but that's not going to give you an answer. Not at all. That's why I try not to share that power curve, because it is misleading. It's not as efficient as others, that I can say, So hopefully it's out there and transparent. We're not competing on efficiency, and we're not as efficient as others. But the reason why we're doing that is because we're focusing on being able to harness the strong wind and being able to deliver 5 times the energy by doing that. So even if we're not as efficient, we can deliver 5 times the energy. That's the important one, the important bit. And that's why I try to avoid misleading people with sharing the power curve.
Understood. Right, Paul's asked, what percentage of the company is now on Crowdcube in shares, and how many shares is that? Now, this is a bit of a tricky. You might have a better answer to this than me, Nicholas, but this is slightly tricky to say because it's a bit of a moving number. So
Yeah.
at the moment, the pre-money valuation of the company is 1.8 million. And so I'm going to choose a number that's easy for maths, even though it might not correlate to the raise ambitions. But if another 900,000 was raised in this round, those new investors would own 33% of the company.
Yeah, but the cap is 500,000.
Yes.
Right. So
yes.
if we're, so reaching the minimum target of 150,000 would mean we would be parting with 7.6% of the company. That's what Crowdcube investors would get, 7.6% of the company. If instead we had the maximum target of 500,000, Crowdcube holders would have 20.9% of the company.
Thank you. That hits it. Okay, another question. We'll go back to the product for a bit. Why do other turbines stop at higher wind speeds compared to O-Wind?
Because higher RPM is a structural risk for their blades. They start vibrating, sometimes they can bend and break. That's basically it.
Thank you. And Ed says that average wind speeds aren't as high as those that you're referencing. But whether that's he's using kind of average or non-city winds, I'm not entirely sure. Can you see Ed's question, Nicholas?
Let me find it.
It's about 10 down. UK wind average speeds won't hit those high numbers.
Ed, UK wind average speeds through though aren't going to hit those high numbers. So how are you going to produce energy if the speeds are there? Right. So that goes again to let me just share my screen to show you just one image. Not the full screen, the application, this one. Right. I'm gonna go back through the presentation. Right, that's the one. So in the right, on the right side, you can see that smaller image, right? Where that's a CFD analysis of a city, computational fluid dynamics. And you can see in light blue, the wind coming in at, say, average speed, 4 to 5 meters per second, which is the average in the UK in open spaces. That goes into the city and funnels in some places you get 0, in some places you get it all together. So in those places, those red ones and dark red, those places can be up to 3 times the energy, 3 times the wind speed, and that means up to 27 times the energy potential. Those are the high energy potential spots that we are targeting, and that's our market case. So that's the way we harness high wind speeds. Not because we're looking at places that naturally have high wind, but because these obstacles take that naturally low wind speeds and funnel them to these places where it can be up to 3 times the speed. So if you have a place where the average is 4, you can have a place where the average is going to be 12. You just need to be able to find those, and we do that with computational simulations, and then have a turbine that can actually use that wind because it's not clean. It's not going to be steady in direction and speed. Blades can break, but we have a turbine that can actually do that, and that's what it's made for.
Thanks, Nicholas. Right, let's see.
Sorry, can I just say very briefly? We do estimate based on research that not in Google research, but on academic research, that there are in cities of 500,000 inhabitants and more, you're going to have at least 20 spots per 10,000 inhabitants. So 20 high energy potential spots per 10,000 inhabitants in large cities. And we are only thinking our market estimations only aim at one spot per 10,000 inhabitants in those cities. And that's a whole business case for that business model.
Understood. Right, Nicholas, let's see if we can get a few others of these sorted. So with the timings proposed, are you afraid that you'll be overtaken by Chinese or other duplicates?
Not really. I'm quite at peace with that. We have seen attempts from researchers and other people who could try to copy them, YouTubers and that, and some have even posted 3D copies on 3D banks, but they never get it right. They have never got it right. We've actually taken a couple of them just to keep just to keep people from thinking that's the one that it's actually true and testing them and not having any results because we didn't really get it. And we keep seeing that, and we keep receiving requests from students who want to copy them to test them. But that's so we're pretty happy with the protection that we have. Our patents are pretty strong. They defend not only the shape of it, but also the working principle behind it. So there is legal protection. The shape is so complex that no one has been able to match it yet. And I'm pretty confident that they won't do that in this time.
Okay, thank you. And someone asks about if this is attached to poles or a wall, can that be felt, or the vibrations of that? Does that have an impact on buildings as well?
Well, we don't have studies about vibration. That's the honest answer. And that's part of the reason why we're going on pole mounts initially rather than building mounts, because after we hit the market with the first version, we're going to be able to do more testing and analysis on vibrations and be able to create a structure that can reduce those vibrations if there are any, to attach them to buildings. So it's just an ongoing process. It's not there yet.
Thank you. Now, Nicholas, Craig has come back about the power curve and wind speed question. It's right at the bottom. It's the three penultimates. I wonder if it's not the right forum to share, either if it's better to have something on screen, or I wonder whether that's something either to follow up direct with Craig, or can be a source of an update with just a bit more of a detailed about the pros and cons of that analysis.
On the power curve,
Yes.
my main concern is that the message is clear. We are not competing with others in terms of efficiency, so the power curve becomes not relevant, and that's the reason we don't share it. But if there is a person who actually understands that, and it's a technical person and wants to become more involved, we can have a more personal conversation.
Thank you. Craig, if you are still on, what I'm going to do is just briefly share the email address, but please do email or feel free to share your email address, and we will set up either a call or something with Nick to go through that in more detail, maybe on a one-on-one call. Now, are you having a look through some of the other questions, Nicholas?
I don't have the capacity to skim through it as
No,
quickly as you.
That's fine. Okay. So Ami asks, how does O-Wind compare to sail type wind turbines? Ami, I think you're still on the call. Yes, you are. By this, I wonder, just to clarify what you mean, unless Nicholas knows, are you talking about the kind of kite sail type wind turbines?
Sorry, the question was how does it
How
compare
does
to?
O-Wind compare to the sail type wind turbines, which might be the is that one's a bit like the kite-based power turbines, I wonder. In which case,
Yeah,
I'd imagine the answer is that they
if
don't need to be launched. They're in permanent position rather than requiring launch and landing.
yeah, no, I'm afraid I haven't analyzed them yet. I kind of assume those were still in development, and I haven't seen them on the market yet. Although I think there was a campaign not long enough, not too long ago in Crowdcube. You may have been close to it, but no, I don't know enough about them. I wouldn't know how to compare them. But if the question
Sorry,
was
no,
about,
is clarified. They're three sails and they're land-based. But if you're not clear on that, Ami, um, maybe I will drop the email address in there, and maybe that can be picked up offline if you'd like to share a little bit more about it, and Nicholas can take a look.
yeah,
Um,
please do that. I'm curious now.
David asks about, could these be good for astrolights, which can't generate enough power at the moment? Could this be achieved in the future? Does astrolights mean anything to you, Nicholas?
Astrolights. I do play football on AstroTurf.
I
But
wondered whether that was it as well. I think actually David's left the call, but I think he's referring to the floodlights that light up the kind of hockey pitches and five-a-side pitches, maybe. Um,
um, no, sorry, I'm not familiar with it. I'm looking at Google Astrolighting, and it seems to be a specific kind of lamp, but I'm not sure about it.
okay. Right. And then Ilga asks, where you're showing these units in situ, is the power supply likely to cover an entire development or for its daily consumption, or is this used in, I'm ad-libbing a little bit here, or is this kind of fitting into an energy mix?
We don't have them yet on display. We have one pilot that can be visited, and there are some rewards in the campaign to add to visits. Well, the amount of energy we expect to generate in the right location, again, it's 3,000 kilowatt per hour per year. That is roughly the same as the average standard household. I think it's the three-bedroom household in the UK. So it's right there with that. It could cover the full expense, provided there are enough batteries to make it even. The full expense of a household in a year. The only thing is, I don't want to make it too direct because it is not for residential use yet, unless you actually have the wind conditions, which is the main thing.
Great. Okay, we're doing quite well. We have still got 20 odd people with us, so thank you so much for sticking with us for a long session. Now, there are a few more questions, but I think most of these are either quick answers or maybe ones that have been partly answered already. So one is there any possibility to use these systems along with hydrogen fuel cells? I'm not entirely sure how that would work, but maybe that means more to you.
In terms of using hydrogen fuel, hydrogen cells, I don't know. I'm not too close to that. I have been approached by
No.
hydrogen production companies, which need clean energy uh, to power up part of the process, which is a different thing. But we're not there yet.
And then this is a point rather than a question, so you can have a brief break. But have you heard of the Energy House at Salford University?
Yes.
They have a huge testing facility. And are
Yes.
you, well, I suppose I'll ask the question, are you in touch with them at all, or is that a potential,
Yeah.
are
Yeah.
you in
Yeah.
touch with them already?
Yeah. I have visited more than a couple of times, and that's where I met the sulfur acoustics teams. And we have been trying to think of ways to test it there, but it will just be too much wind for the internal space. But it is a great project, and I do encourage people to visit it.
Excellent. Andrew, I'm going to just drop into, I've just put an email address to reply to your question. I wonder whether, because you've got a couple of questions in there, whether to set up a separate call one-on-one with Nicholas or send over the emails directly and or questions or in email and hopefully get a fuller, more in-depth answer that I don't think we're going to get round to today. A quick one from Philip, if he's still here. Yes, he is. Do you have a link to a wind assessing company?
Yes, I can share that in private.
So I will again just send a email and yeah, please follow up, Philip, and Nicholas will get back to you. Now I think the others are probably slightly duplicative. Um, there's one asking about the payback, but I think we covered that already. There's still the question about whether you can do some quick calculations with roughly how many solar panels would be the same, but maybe that can be a source of an update on Crowdcube
Yeah.
um, if it's not something you can do in your head quickly now.
No, it will take me roughly half an hour.
Okay,
I have done that before, estimating different solar systems for a friend of mine. But half an hour, we just don't have it. Sorry, I
great.
can do it.
Okay,
I can do it afterwards.
great. And have you come across OmniWind of, I think that's the Netherlands? Have you come across that company?
No.
Okay. That's maybe one to have a look at as well. Sorry, we can't give any more in depth at this point. Can you hear me okay, Nicholas?
Yeah, just one of the headphones one run out of battery.
Okay.
Still got the
No,
on one.
I think we've got through. I think we covered the one on the strongest wind the turbines can take. Um, have you got the questions open in front of you, Nicholas? There's just two left. I think we've got
Bring them
down
up.
to.
Okay. Horsepower validated. We have run several tests. The latest one with this group of engineers from Lancaster University, and the power output comes in the form of a CSV file. That's very much it. Independent test we haven't done yet, but that's what we want to do with this race. We want to build the first one, place it with the customer, so it's there in public and someone else can validate what we're saying. Last question. Wind blowing with 90 kilometers per hour is the strongest wind the turbines can take. Are there plans to cover areas with more wind too? Just off the top of my head, I think that's roughly 25 meters per second, but not quite sure. But 25 meters per second is the cap and the higher limit. Cover areas with more wind too? Yes. I mean, the only reason why we have limited to this to this wind speed is because the testing capacities are up to that point. We have managed up to 28 meters per second, but more than that is roughly hard to test. And the mechanical restrictions, the mechanical stress gets higher and higher. So at that point, we're very confident that we can deliver and that it provides enough electricity for it to be a good match for the market, so we can go to the market with that. We don't want to keep spending years and years on ROI if we have something that can already deliver. But then that said, we can still keep developing in the future. And if we can do more on that, then yes, of course, we will try to do that.
Great. Nicholas, very well done for getting through the questions. I don't think I've ever seen so many, which is fantastic. So thank you everyone that's stuck with us for the full 90 minutes. Really appreciate asking questions. Nicholas, you'd like to say something?
Yeah, sorry, just to answer to the previous one, which I didn't know about. O-Wind, I just checked it quickly. It's a vertical axis wind turbine placed in the middle of two half spheres, like in opposite. So they drive wind a little bit. But I don't think much about it. I haven't seen the data. But one thing I can say is omni means all, right? So you use that for any word. All winds should include downdraft, updraft, and diagonal. It is really all winds. The word has been misused by competitors from a long time, and I've seen it in patents, and that's actually have been one of the challenges, because patent reviewers come back saying this other one is also omnidirectional, and it's not, because it only takes wind horizontally, north, south, east, and west, but not downdraft and updraft and any other thing. So that's a challenge to the industry, or maybe an educational challenge for myself, because we need to bring the concept out there. That's why we started calling it 3D omnidirectional, which is repeating on the same thing, but I think it's more clear on the message. Omnidirectional is not just on the horizontal plane, it means all winds, and that's something we need to take through.
Great. Thank you very much, Nicholas. And thank you everyone for taking such a chunk out of your Friday afternoon. If you click the chat button now, you should see my last message, which, like I said before, has the link back to Crowdcube. Please go and check out the page. Nicholas, and I'm sure would love to have you, as many of you as possible, on board. And it's, although we got through a lot of questions, it sounds like some of these could have been good questions, good conversations as well. So please send an email to inquiries@o-innovations.com to either set up a call with Nicholas or ask questions. And I'm sure Nicholas will get back as soon as possible. But thank you. And thank you very much, Nicholas.
Yeah, thank you, Steve, for organizing all of this. I couldn't have done it without you. And thanks everyone for your interest. And I really look forward to having more conversations. If anything is unclear or needs further clarifying, I'm more than happy to jump on a call one-on-one. And yeah, looking forward to your support on the campaign.
Great. All right. Thank you, everyone, and have a good afternoon.
Thanks.
Bye-bye.
Bye-bye.